Exactly. What Baby is saying here is welcome to this second video in Python, looking at the Ursina 3D engine by Petter Amland. And we'll have a look at his websites in a moment. And do go and support him on Patreon if you're in a position to do so. So last time, I just showed you how to set up Ursina and things. So see the previous video if you want to know how to install it and just get going. But here's our program with, about 20 lines, maybe less. And what this does, let's just run the module now. It creates a cube on screen that we've textured, and we've got rotations happening. So that's what's going on. And to stop the program, I'm still having, I've covered it up again, but in the top right here, by default, there's like a red X where you can close the window, but that's not working, certainly on my Mac. And I think other people are having trouble with it on Windows machines. At the moment, it's 2021, April. It may have been fixed by the time you're watching this video in the future. So to close down, on my Mac, I'm just using Alt, Command, Escape, and then I can force Python to quit. So I can bring down the window like that. Oh, did I also last time? Oh, sorry, we already overcame that problem last time. In the input function here, where we're taking a key, and this will work because of the Ursina module. It takes a key, and I'm saying if that key is escape or Q, then it quits. And let's run that again, and then we can close things down. So while I'm just running this, we can talk about what we want to do. So we want to get a solar system, and I might make a few videos to do that. Okay, so we can press spacebar to increase the scale, and if I press Q, then our program stops. So that's a nice convenient way that will work on Linux, on Windows, and on Mac machines if you're using Ursina, just to overcome the problem of the window not shutting down. We've got the editor camera, actually. We're using the editor camera, which means if you press the right-hand button of the mouse, or on a trackpad like me, 2 fingers, and then you can use WSAD to move around the scene. There's not much of a problem when you try and quit, because you can still use your mouse. However, if you're using the first-person camera, let's do that now. So we can say player, I like to say subject. You can use whatever variable name you like, equals first-person controller. And Ursina literally makes it as easy as that to have now a first-person controller in our scene. That's a little bit of a lie, because first we do have to just import. We have to import the first-person controller prefab, which I've forgotten exactly how to. I've forgotten the terminology for that. So let's go to the wonderful documentation that's included with Ursina. So if you just go to ursinaengine.org, you can then easily get to the API, which is what I'm looking at. You can have light mode, dark mode. And so I just want to look for first-person controller. Let's have a look. And then it should tell us exactly what we need to do. So you can see all these different things that you can do with Ursina, by the way. I just saw sky go past. I think literally you can write sky, and then it will create a sky for you. So that's probably how we're going to add stars and things. Yes. I can't see. Oh, there's a mouse. I can't see the first-person controller. Animation, draggable. I'm really sorry if you saw it as I was. Oh, there it is. So you've probably now seen it twice, and I missed it. Oops. Right. That's what I'm looking for. Ursina prefabs first-person controller. And so on this documentation, you're not only getting explanations, you'll get a little example piece of code that you can copy and paste in. So we want from ursina.prefabs first-person controller, import first-person controller. Well, I don't usually like to copy and paste. It's kind of like a bad habit. You don't tend to learn how to do things yourself. But let's just do that now to speed things up. Talking of which, I've actually got a deadline for this video. When it's about 10 past 10, I've really got to stop. So now let's save our module and run. And I've done something wrong. Invert. Oh, right. There you go. Try that again. Give baby a little bounce. Right, so now we've got a first person controller. I wasn't looking at the screen. Whoops, now just, where's the screen gone? There we go. So presumably I'm looking around the scene, I'm walking around, but there isn't anything. Can I press Q? Yes. So what's now happened is the first person controller takes away your mouse control. So there's no way, certainly on a Mac, to easily get the program to shut down. On Windows, I think if you press a Windows key, you can then navigate down below and close the program. So this is where it's really handy to use Alt, Command, Escape, and then force quit, and then you can get out of there. That will save you, if you didn't know how to do that simple thing, that'll save you hours of trouble. So that's why I show that. Right, so there's the first person controller. So let's keep that here for later on. It'd be interesting when I watch this video back if I actually saw the cube and then your first person controller kind of like fall away from it. Presumably it's using gravity. Sorry, I wasn't paying attention when that was happening. Right, so the first thing we need to do is change our cube to a sphere. So this is where we're dealing with input. This is our update. Oh, this is our update loop where we're just changing our cube called Simon. We're changing its rotation. And here's where we're actually creating our entity. If I add some spaces there, we can move this to the top. Yeah, that's Simon. You like Simon, the cube. And there we're making it into a cube. And there we're adding the texture, Texie, which is this texture here. That's just in the folder, the same place where your Python file is, your module. So that's what I'm using, the second tutorial. So as long as it's in the same folder, or if maybe you've made a folder there called assets / like that, maybe I'll do that now. Where's my, did I close it down? Where did my files go? I'll have to go there again. So mine's in GitWeb, Python, Ursina development, tutorials. Right, I wanted to keep this up. So new folder, we'll call that assets, and then we'll put our assets inside of there, like that. And you know what? Let me just copy this. I'm going to put this counterintuitively in here as well. So that, by the way, I've linked to my GitHub repository of this in the previous video, and I'll do the same in this video. So I'll just put that back there because this first example file, it needs to know where this is. It's got to be in the same folder. But now we'll do things a bit more properly. We'll structure our folder, organize it a bit better. Right, I'll minimize that. So now what I want to say is, yeah, assets, Texie, and this should still work. But this time, let's have a sphere. And this is not going to be Simon. This will really be our son. What should we call our son? Let's just call it son. I'm taking my time making this. So let's also take, okay, let's just see what we've got so far. Run module. And then we want to think about changing the size of our sun. We could add some transparency. So there we've got our sun at the middle of our solar system. And what we want to do is create load more. Whoops. I just pressed the space bar and that's not working. What we want to do is create loads of more planets, or spheres, and then get them rotating around. It would be nice if we also get the right amount of planets. And we could even, use some data online for what colors they should be and things like that. So I haven't changed Simon to sun there, and that's why we got that error. There we go. Right. So one major thing we want to do is, instead of having to do this kind of thing, to make a new entity, to make a new 3D object, we don't want to be writing something like this and blah, 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 and then having to do that copy and paste that loads of times. I don't know why they're coming on weird tab spaces, sorry, and then changing all of these names and then trying to sort it all out. That would take too long. And maybe you want 1,000 planets in your solar system. I know I do. So what we want to be using is a class of planets that we can easily change. So let's do this now. Let's create a new class and we'll call it planet. And then we need to initialize our class with some details about our planets. Okay, so that's better. Sorry, class with a small c. And we need to initialize it with, usually you'll see in Python this being used, self, which just stands for each individual instance, or individual, in my case, planet. It's going to be stored in this variable, and you'll see how that's used later on. And in Python, you'll see it be called self. I like to call mine this because I've learned other programming languages. That's where it's called this, and this kind of thing will be called this. So don't worry about that. So what we want to say is this will have an entity attached to it, i.e. an Ursina entity. And I might just call that ent. And that will equal a new entity. And this is where now we only have to write this once because it's containing the class, which is like a blueprint for making 1,000 planets. That's the first thing we'll do to test if this is working. And now we can just do this and say our model wants to be a sphere. Our texture wants to be, actually let's have no textures at the moment, but we'll say scale equal, oh dear. We'll say it's scale, certainly 7 minutes, and we'll finish the video and go to the next one. Scale equals rand s, and that will stand for random size. So before we can kind of set that, we have to say rand s equals random. One second, let me just pause the video. Hello. So I just made little baby a little happier. Okay, so he's gone. Don't worry, he's not only is he okay, he's much happier now. Right, so what we're just doing is setting a random size or scale for our 3D object or our entity in Ursina's language, or planet for our project. So random equals, I need to import the random module. So import random, and I'll just call that as RA for random, okay? So now I don't have to write random dot whatever function I want. I can just write RA because I'm calling it RA up there, this module, and its functions. So, and I want to use rand int, which will give me a random whole number, and I want to go from, it can be between 3 and 24. We'll see what size of that looks. And so we're going to set, we'll see how, we'll set the scale of our entity to that size. We also need a color. I don't think we did colors last time, so this is new. So American spelling of color. Color equals, and again, let's do a random color. We'll say color equals color dot RGB, RGB, like that. So these variables don't exist yet. So again, let's do something very similar. We'll say red equals, we want a random integer from, so if we go too dark, it'll be from 0 will mean like black or no red, and 255 will be the brightest or most intense red. So we'll say between 100 and 255. And then we want to do exactly the same for the amount of green and blue. Right, we can also have transparency here if we put A and then A. So let's try that as well. So that's like the alpha channel. So the lower it is, the more transparent, or the higher this number, the more opaque, like a brick wall, you can't see through it. And so that will just go from, I don't know, about 100. Oh yeah, about it's about the same. Or let's make it really low, 42 to 255. Okay, we'll save that. Okay, so let's just check. Oh right, we haven't positioned our planet yet. We could do that in the initialization, but let's do it when we actually create our planets. So far, although we've written our class for our planet, we don't actually instantiate any 3D objects there, so we won't see any planets yet. We will see the sun. Let's just see if things are, I haven't broken anything, because we've actually asked Ursina for a new entity. So if we call this function entity and then set its parameters, properties, then we'll get that 3D object in the scene. But we haven't actually instantiated anything from this class. So I've done something wrong here. Invalid syntax. What have I done wrong there? Do I need a capital I for initialization? I'll just look at my other code. No. Again, send in your answers if you know what I've done wrong here. So I want to go to, yes, my folder. And I was just playing around with solar systems and things here. Why is this not opening up? Or is it open down here? I don't see where it is. Let me just use my new pause function. Okay, I found it. I just opened it from idle. I don't know why I wasn't able to open it by just double clicking on the file. So there we go. So in this one, I was preparing, but oh! I didn't use the definition keyword for creating the initialization function. There we go. Right. Now let's just run it and see what's happening. So we should just have our rotating sun with my chicken texture on in the middle. And now if I press space, yes, I can increase the scale of that. Fantastic. Press escape and we can close down. Wonderful. So let's make a loop of planet for creating lots and lots of planets. So, and that's where we'll set the positions of them as well. So first we need a list so we can deal with all of our different planets. So we'll call that planets. To make a list we use a square brackets like that. Planets equals that. Let me comment this. Our list of planets. Now we can have a for loop. So for, and we'll just call each individual planet P temporarily in the loop. So for P in planets, no, we haven't. For P in range, we want to go to, let's say, 100 planets. Now we can say P, no, we'll say for baby, for a baby planet, baby equals new planet, and that will create our planet for us. So if we write that just like we wrote sun equals entity, now our class planet will create a new planet for us. So it's going to store that planet in the this keyword as an object, and first thing it will do is create all these random variables, and then it will create an entity using the Ursina engine, make it a sphere, give it a random scale, give it a random color, hopefully with some transparency. Then what we want to do is set its position, and then we can, or after that, we can add it to the planets list. So at some point we want to say planets append baby. And what that does is put this object that we just made, this planet, onto the planets list. And so once we've got 100 planets, they'll be listed at the indexes, or indices, 0 to 99 on that list. So if you've used arrays in JavaScript and C and things like that, a list is essentially an array in Python. Right, so we want to say baby, that's our new planet, its entity has a position x, and we can say that will be, let's just get them lined up, because we've got this number in our loop, p, which will go from 0 to 99. So we can say your position is p minus 50, we'll say. So x position is going from left to right, and then we maybe want to space them out a little bit, times 20, something like that. Right, now let's see if this runs. Okay, let's see if we get a line of multicolored planets, or planets of different color. Right, I can only see our sun. Oh, I can see something though. I didn't think this was actually going to work. It's actually worked. So there we go. We've got a line of planets. They're kind of like pastel coloured because of the way I've generated the random colours. But that's really cool. That's looking exactly as we expected. That's weird. So again, not my skill as a programmer, but how easy and intuitive Ursina is. Right, so we're going to end this video just about there, where we've done kind of the hard work, in that we've now got, oh my goodness, not 1,000 planets, I want 10,000. There we go. Let's just set their textures as well. And in fact, where is that? So I only have to change this in one place. I'm going to change it in, and we'll call that 2K sun. No, 2K moon, I think it's called. I've got another texture set up. So 2K moon, if I just copy this texture, it's just a JPEG file, and put it into our assets folder. 2K moon. Now Ursina, or our Python script, can find it. And we've made 10,000. Save and run. They were looking a bit too transparent actually, so let's just change that transparency to, oh yeah, I did say it's quite low, didn't I? And now and we'll move them back a little bit so they're not overlapping the sun, which is actually really small. So we maybe want the sun's scale to be, I don't know, what's the random scale? Random scale can go up to 24, so we want you to be 64, so a really nice big sun. And what was I just doing? Oh yeah, just moving them backwards. So in our loop of 10,000 planets, we then want to get hold of the planet's entity, which is like its Ursina body, 3D object, and we want to say its Z position equals, I think if we go on the minus direction, it goes like into the view. And let's go, I don't know, 80 steps, 80 units that way. And let's save that. Now what we could do is, I've done something wrong there, sorry. Oh, I missed out a comma up there. What was I saying? Oh, we could set the position of our planets, randomly pick a position and a rotation thing. We could do that when we instantiate the planets. This is taking a little while, I think, to create our 10,000 planets rather than going wrong. Let me just pause the recording. Right, sorry, just pause it again. Let's just see if we can see our planets. I had to step away, in fact, so I don't know. Whoops. What? Oh, I think this was... Oh, I think we may have been... Oh, because our sun is created at 0, 0, 0, i.e. in the middle of our 3D world. So baby's back as well. I was looking after baby just now, so I don't know how long that took to load. But here are 10,000 planets. I've just used a moon 2K texture. And you can see, usually when I'm using Python and graphics, certainly, the performance is terrible. But, 10,000 entities, it's pretty smooth. It's definitely a bit juddery. But there we go. Right, we'll leave it there for that. It's almost been half an hour for our first, proper solar system planet program. And the next video we'll get those rotating. I want to use some real planet data, so we have a kind of accurate solar system, our solar system. Do we have a name for our solar system? We've got obviously Milky Way for the galaxy. But I don't know what our solar system... We should name it in the next video. Also, I just wanted to show... I did show the documentation for Ursina, but I also want to show you Petter Amland's Patreon. So he's the creator, the genius behind the Ursina Engine. So do have a look at his Patreon. Also, I believe he's some kind of amazing artist. So this is our artstation.com. I can't believe this, but I think this is the same guy. And I was just looking now just to find this again. But I found, I think he's got a SoundCloud as well. So he may even try some music. This may be a completely different person. So I haven't confirmed that. He's also on Twitter. But yes, all of this is possible because of this this fellow here. So thank you very much, Petter, if you ever watch this video, for your wonderful 3D engine. Let's just go back to the code. Right, I'll put a link to all of this code. Well, it's very small still, very small, in the description. So thank you very much. Goodbye from baby and myself. Goodbye.